Hi, today we're going to talk about more multiplication properties for exponents. So let's put your name at the top of your paper. Great, let's begin. So here we're going to grow our skill that we worked on yesterday about multiplying properties of exponents, the same base, and working with just what's happening with the powers. So this particular exponent rule that is exhibited here is usually referred to as the power to a power rule. And the power rule, or the power to a power rule, simply states that a to the m to the n power is equal to a to the m times n. This is where the exponents actually get to multiply to each other. And it's very common for me just to help people remember that if you see parentheses and an exponent outside of the parentheses, I usually say, ogres are like onions. They have layers. Your parentheses are your layers. And they tell you that there's more happening there. There's a deeper meaning, a deeper understanding. So here in our first example that they gave us, we have d to the third power all to the fourth power. We see this set of parentheses. And using our rule, we can multiply the 3 and the 4 and come away with d to the 12th power. And that's it. You're done. If we wanted to expand that and just grow our skill to a little bit more involved, sometimes parts of the example have parentheses and some don't. So in your order of operations, you have to deal with your parentheses first. So let's do that. So here, we're going to tackle this portion of the problem first with our power to a power rule, and we multiply the -3 and the 6 together to get -18. And now we use our rule from yesterday where we have the product rule. And we'll write that. Remember that from yesterday, the product rule? So let's add and subtract these exponents of -18 and 4 together. So the bases were multiplying, so let's add them together, and we find out that n to the -14th is your result. Now, if your instructions say, that's great, but I want you to make sure that you write this using all positive exponents. This is where we use our reciprocal. And we did this, I think 2 days ago. So we remember that an integer always has a 1 underneath of it. So you flip it over, you flip the base over, you do the reciprocal, and the exponent is now positive. And this is your most simplified final answer. Great. All right. Let's go look at a word problem. So we looked at problems similar to this yesterday when we looked at the product rule. And we had the scientific notation to work with. So if I have this whole quantity in the parentheses, I have to distribute this exponent to each piece inside of the parentheses. So the 4.2 is squared, and the 10 to the negative 7th is squared. So if you use your calculator, 4.2 squared becomes 17.64. And then negative 7 times positive 2 makes negative 14. Now you remember that you're only supposed to have one digit to the left of the decimal space in order to be accurately written in scientific notation. So when we move this over to the left 1 unit, you add that 1 unit to your exponent, and that is where the negative 13 came from. This is your final answer. So that is something that you actually worked on in probably your junior high science class, and it's just been a while. So hopefully that'll come back pretty quick. Let's go turn the page and do lots of examples to grow some great skill together. Okay, problem 1. Let's simplify the expression. We have a nice little problem where I just have y squared cubed. Okay, power to a power, y squared times 3, y to the 6th power. Done. Love it. So easy. I bet you can do number 5 right below it. Give it a try. I'll wait for you. Did you say p to the negative 1 times 5? What is a negative times a positive? Yeah, it's a negative. 1 times 5? 5. P to the negative 5. Done. Isn't that great? All right, let's do number 9 together. So here I have 2 pieces of information inside of the parentheses, and I am going to distribute this 4 to both of them. So this becomes 3 to the 4th power, and then a to the 1/2 times 4. All right. What is 3 to the 4th power? You have a calculator and a great brain. Let's think. 3 times 3 is 9. 9 times 3, 27. 27 times 3, that last one. 81. Good job. A. Let's see, 1/2 times 4. What is half of 4? Yeah, it's 2. There you go. Finished. Okay, let's do number 16. No, what am I saying? I don't know. 13. Let's do number 13. So here we have a lot to distribute. This 3 is going to distribute to the 2 and the negative 5. This 2 is going to distribute to the 11 and the negative 10. So this becomes 2 cubed y to the negative 5 times 3 x to the 11 times 2 y to the negative 10 times 2. What is 2 cubed? Do you know? 2 times 2 times 2. Oh, that's 8. Y to the negative 5 times 3, negative 15. X to the 11 times 2, 22. Y to the negative 10 times 2, negative 20. Is it finished? No, it's not. I have a y and I have another y. I need to bring them together. Which rule are we going to use? Is it a reciprocal? No. Is it an exponent of 0? No. Is it a product rule? Are they multiplying to each other, those bases? Yes, they are. So the product rule says to do what with your exponents? Good job. You have to add them. Let's do this. So we've got 8. My x to the 22 is just here, chillaxing. Y to the negative 15 plus a negative 20. Yeah, we're definitely running out of room. This is a great example when it might have been better to use a separate sheet of paper to help us out. But we'll figure it out. It'll be okay. So here we have 8 x to the 22 and y to the, what is negative 15 plus a negative 20? If you went 15 feet down and then another 20 feet down, that's right, it's negative 35. Wow. There it is. Okay, I want you to try number 2 through 16 on your own. Pause the video, come and ask me if you need some help or if you're ready for me to check it. All right, let's look at problem 17 together. So in 17, I have 2 quantities of information inside of my parentheses, and I am going to distribute the 3 exponent to both of them. And I have to make sure that my answer is in scientific notation when I'm done. So I have 2 cubed times 10 to the negative 8 times 3. What is 2 cubed? That's right, it's 8. Good job remembering. Times 10 to the what power? What is negative 8 times 3? Negative 24. Good job. All done. Let's do number 21. We're going to distribute this 2 to the 6.7 and the 11. So 6.7 squared. Let's give ourselves some extra space. I just have a suspicion we might need it. 6.7 squared times 10 to the 11 times 2. What is 6.7 squared? Do you have a calculator with you today? I bet you do. 6.7 times 6.7. Good. It's 44.89. Did you get that? Times 10 to the, what is 11 times 2? Ha! It's 22, just like that little 22 right there. That's funny. Okay, the rules of scientific notation say that you can only have 1 digit to the left of the decimal. So we're going to move this over and then add that 1 movement to the 22. So this is 4.489 times 10 to the 22 plus 1, because we moved it over 1 unit. All right, final answer time. 4.489 times 10 to the 23. Nice. Okay, I want you to pause the video and look at 18 through 24. See if you can, actually 25. See if you can get those on your own. If you get stuck on 25, come and talk to me. I'll help you out. Last section for this handout, so exciting. We need to determine what multiplied to create this new exponent. So this is, again, power to a power. So 3 times what will make 3 halves? So another way to do this, if you wanted, is to work it backwards and just say 3 halves divided by 3, which is the same thing as 3 halves times 1/3. What do you get? The 3's cancel out. 1/2. Some people could just look at this problem and they would see it. Oh, it's 1/2. What? And you're right, it's 1/2. Other people need a little bit more of, how did you get that? And that's fine. We'll just take time and we'll figure out how to get that. Working backwards. All right, number 29. How did I go from 11 to an answer of 1? Like it's 1. The whole thing is 1. Hey, I know how to make a 1. What's that sneaky little rule that makes everything turn into a 1? The exponent has to be equal to, you remembered, 0. So k to the 11th power all to the 0 power will make 1. That's right. So these last couple of problems are like little math puzzles, little baby math puzzles. So your turn, 27 through 31. Let's knock it out and come and tell me when you're done or if you need some help.